Let's take a look now at how we can use limit notation to describe the end behavior of a graph, which is really what a horizontal asymptote is all about. You may have heard that it's a line that a function doesn't cross. That's not really true. In fact, we'll look at a function later on where the function does cross its horizontal asymptote. Instead, a horizontal asymptote really describes the end behavior of a graph. And so let's take a look at just the parent function for rationals f of x equal to 1 over x. And remember, when we take a look at a graph of this function, that what's happening is as x is getting really small. In fact, we focused on what happens at x equals 0 quite a bit, but I'm getting this kind of behavior right there, where as x is going to 0 from the right, I'm going to infinity. And then my function kind of smooths out there as x is getting really large. Think about like 1 over 10 and then 1 over 100. I get closer and closer to 0. And then I've got the same kind of behavior going on for x values that are negative, except because they're negative, it flips it over over the x-axis. And so I get something that looks like that. Well, what we focused on so far is the idea of as x is approaching 0, we could say from the left we're going to negative infinity, from the right we're going to positive infinity. But the bottom line, as we approach x equals 0, we know from topic 1.14 and other topics before that there is a vertical asymptote at the vertical line x equals 0. And we know that to be true because if we look at x equals 0 and we use our direct substitution technique, we get 1 over 0. Non-zero divided by 0 result tells us right away that there's a vertical asymptote there at x equals 0. But we also focused on this graph, and in fact I kind of described it as we were drawing this graph, that there is in fact a horizontal asymptote that the graph shows. So there is in fact a horizontal asymptote for this function. And in fact, I kind of alluded to it. I said as x was getting larger, like 1 over 10, 1 over 100, that the function values are getting really close to 0. And in fact, that's my horizontal asymptote for this function, is y equals 0, that horizontal line y equals 0. So the question in front of us right now is, how do we express this? How do we express this idea that there's a horizontal asymptote at y equals 0 with what we know with limits and our concept of infinity? Well, if we think about how we already just described it, we said as x grows really, really large, the function values approach 0. Again, 1 over 10, 1 over 100. So if I want to use my limit notation to express this, I could say the limit as x grows really large implies the limit as x approaches infinity of my function f of x. So as x is growing infinitely large, and again this idea of end behavior all the way towards if there were an end of the graph, what it would be doing, and the function would be approaching 0. Now when we talk about horizontal asymptotes, we could have them as we approach infinity moving from left to right. We could also look at what happens as we approach negative infinity from right to left. And if I look at this function as x approaches negative infinity, so as I'm going out towards negative infinity, well, my function is also still approaching 0. And so this notation right here actually gives us a formal idea of what in the past we've described as a horizontal asymptote. And now we're going to look at some various analytical ways of figuring out where horizontal asymptotes are on a graph.